And here's our pregame walkthrough, if you will. We're going to go through this example on the board, and I've got some command output here for you as well. I'll point out a couple of things of interest along the way, and then we'll do a more complex example on live Cisco switches. So the configs here came from live switches as well, so it's good stuff to see. Let's go ahead and take a look at what exactly is going to happen here. First, we'll start on switch 1. Now, we have 5 default VLANs here. Only one of them is going to be populated, and that's VLAN 1, and that's of course our default VLAN, our native VLAN, and all the ports, all the access ports that is, are members of VLAN 1 by default. You may never use VLANs 1002 through 1005 in your life. I would know them. And just know the numeric range. You don't have to know which ones are for FDDI and which ones are for token ring. Can't believe I'm still saying token ring. But you need to know those VLANs are defaults and they can't be deleted. In the output of this command, though, in the board and in my study guides, I will edit it out at this point. So we've got those 4 bottom VLANs out, but we know the range. We know that all ports belong to VLAN 1 by default, but this is a 12-port switch. Where are my other 2 ports? If I'm information gathering or troubleshooting a brand new switch in a network I've never worked on before, show VLAN brief is a good way to get started. But another great command is show interface trunk. Because when you make a port a trunk port, it's a member of all VLANs. That's what a trunk port is, where an access port is only going to be in one VLAN. You see your access ports and your access port VLAN membership with show VLAN brief, then you run show interface trunk and see your trunk ports and what's going on there. So we knew that our trunks were up and running at that point. To see a switch's values for a particular VLAN, you run show spanning tree VLAN followed by the number, because what we're running here is per VLAN spanning tree, PVST. And then there was a PVST plus, but people dropped the plus, and now we just call it all PVST. That's why we have to put the VLAN number in. With per VLAN spanning tree, each VLAN runs an independent instance of STP. If you try to run this command show spanning VLAN for a VLAN that does not yet exist, like 75 that I did here, it's going to give you a message right there, spanning tree instance for VLAN 75 does not exist. That's because the VLAN doesn't exist on the switch. Fortunately, that's not what I got for VLAN 1 on this particular switch. And let's look at the output here. I've bolded root ID and bridge ID, and I got priority in there as well. And remember, the root ID information is about the root switch. The bridge ID information is about the local switch. So we can see that we are not on the root because the MAC addresses of root ID and bridge ID are different. Also note that FAST11 has been put into forwarding status, but FAST12 has been put into blocking mode. Okay, and we'll talk why in just a second. As a matter of fact, let's go over there and do it right now. We know that the bid of any switch is the priority followed by the MAC. When we compare the 2 values, the root ID and the bridge ID, you can see they both begin with the priority, and of course the priority is at the default, 32768 plus the VLAN number, which in this case is 1. So since both devices have the exact same priority, the switch with the lowest MAC address gets named the root, and that's exactly what happened here. And this is a good idea, this is a good reminder that it's important to know your hex, because you could be presented these on the exam and be asked, okay, which one's going to win the election? Well, you have to know that B is lower than F in hex, because you can see the MAC address of the root ID is 000B, or it begins with that is, and the bridge ID, the local switch, is 000F. So we know why the root bridge won that particular election. Now we saw on switch 1 that FAST11 is in forwarding mode and that it was marked root. That's the port that switch 1 is going to use to reach the root switch. So FAST11 is switch 1's root port for VLAN 1. Now 12 is in blocking status, we saw that, but how did the switch decide that? How did the switch say, okay, 11 you're in forwarding mode, 12 you're in blocking? Well, the switch first looked at the path cost, but they were equal. They were both 19, which is the default STP cost for a fast Ethernet port. Well, the tiebreaker there is the port priority. It's found under the prio.nbr field, and we can go back and take a look at that, and it's the very next value, prio.neighbor, and it's 128.11, 128.12, and that's why port 11 was elected or chosen as the root port. So we've marked that on the exhibit, and we move on to switch 2. And then I ran the same command, show spanning VLAN 1, on switch 2. And you can see that this bridges the route in a couple of ways. First off, there's a big whopping message right here that says, this bridge is the route. So that's a hint. And you also see that the MAC address under route ID and bridge ID are exactly the same, and that is another hint. Now, we've got that. Both of these ports are in forwarding mode, 11 and 12. That is another tip-off you're on the route, because a route bridge is going to have all of its ports in forwarding mode. And those ports will be named designated ports. That's just the route bridge behavior. We'll also see a designated port in our next lab, but do keep that in mind. These are not routes. You know, it's really easy to say, okay, on the route bridge, all the ports are forwarding and they're route ports. But route bridges don't have route ports. They don't need a port to reach themselves. They are themselves. I know it's kind of zen for a networking course, but that's exactly what happens. So in the end here, we have 2 switches, two connections, 2 trunks, 4 ports involved, but only one of them gets put into blocking mode. Isn't that wild? You would think it was 2, but it's actually just 1. And that ends our 2-switch discussion, our 2-switch walkthrough. In the next networks, as a matter of fact, I believe I've got the diagram right here. I'll go back to that text that we just had. But here's the diagram for the next one. So we've got 3 switches and we've got a full mesh. And so we got all kinds of things going on, and we will check them all out on the next video. See you there.